Hey, welcome guys. My name's Scoops Martin, and this is my bowling kata. Start off by getting our test suite running. Then we're going to describe this is our bowling kata, so it shows up in our test. We want to make sure that it scores a game that you do all gutter ball rolls on. So it should equal 0. And then we're going to have the get score function. We haven't created it yet, but let's go ahead and put that in there. We're going to take 20 rolls of 0. So the first thing we're going to do is go over to our actual code, create the get score function. We have that running, but it fails because it's not getting there. But let's add 0. Alright. So next let's try an all ones game. This one should equal 20 points. I'm just going to paste what I had before, but change it to a 1. So our best way to go about that is to make a reduce function. It adds every roll together and then outputs a score. Now let's see if it can handle a spare followed by all ones. Got a little typo here. Let me go back and fix that real fast. If you had a spare followed by all ones, you should get 29 points. We're going to do get score. This time we're going to do a conjoin, because conjoin on a lazy sequence will add it towards the beginning instead of the end, compared like a vector would. And 5, 5. Alright, I'm going to actually create a loop. This is basically like we need to convert everything into frames so it has a way to check to add up. So iteration 0 rolls, result is going to be an empty vector. That way every time we add something it goes to the end of it. Let's see if we get to the 10th iteration, because there's 10 frames. We're going to increase the iteration. We are going to drop 2, both those rolls, and then I'm going to go ahead and deconstruct this, because I know I'm going to use a lot of the rolls and it'll get a little repetitive doing first roll, second roll, third roll. Take that from the rolls. Then if the addition of the first roll and the second roll equals 10, I want it to add roll 1, 2, and 3 together and add it to the result. So we can do the conjoin again, but now that it's a vector it will add it towards the end compared to on the right side in our test side where it added it to the beginning. And let me go up here and copy this. And paste it there, and just adds 1 and 2. So that way if it's a spare, and look, passed that test. Now that we've passed, let's go ahead and refactor this. This is not readable. Let's give this its own function. We'll call that function get frames. Alright, and we're going to make this a private function. Just needs rolls. There we go. And I think we can break this down a little further, make this more readable. Let's do one, let's call it score frame. It does need result and rolls. And I think result and rolls. And we are still working. See, that's the benefit of these tests, is you can really kind of check if everything's working at the same time while you're refactoring. So let's go ahead and see if we can get an all spares game to work. I believe our logic's there, but you always should check. You have 21 in an all spares game because you get that bonus. And we're still working. So let's go ahead and set up our next test. We're going to check if a strike will work. Strike followed by all ones. And that one should equal 30. And we're going to use our conjoin again, because once again, if it goes on a lazy sequence, it adds it to the beginning. So it'll be our first frame. Well, immediately we see that we get an error. And that's going to have to do with how we're dropping the rolls when there's not as many rolls in the game. Let's start with an if statement. If the first roll equals 10, that means it's a strike. So we're just going to do rest as the way to basically drop one of a sequence. You could put drop one, I think rest looks a little better. And we need to figure out the scoring side now, and it looks like we just need to make a strike condition because it would add roll 1, 2, and 3 because the strike is only one roll. So if strike or spare, and it looks like we are passing. So now's the time. Let's make this a little more readable. We know that's a strike, but somebody else wouldn't be able to see that. Let's go ahead and break that down a little bit. Strike question mark, that kind of leads the whoever's reading it behind us to know it's going to be a Boolean statement, true or false. Let's go if equals 10 first roll. Yeah. And looks like we have an error. Oh, I see. I think we have a typo right here. And are we working now? Yeah, we're working. So you can see the benefit of the test-driven development. Your tests are already there to see if the refactoring's working. Real time when you're working on it. And let's go ahead and change this one too. And we're still working. Let's go ahead and create one. Let's get this out into its own thing. It's a little less readable. Drop rolls, it describes what it does, but you don't have to sit there in that whole function. Let's have each function do one specific thing. There we go. And let's go ahead and make one for spare over here. Just makes it a little more readable. Alright, and I think our last test we really need to check. Let's just see if it scores a perfect game for us. Tidy up things real fast. Look at that. Nice, neat, easy to read. So, all strikes game. Let's just call it a perfect game. Perfect game is a little more readable on the test. And a perfect game is 300. And you just only get 12 rolls. And we passed. Well, thank you for looking at my bowling kata, guys. Until next time.